When completing this type of problem, I like to write them out, especially when there's a highest common factor and a lowest common multiple. I like them in expanded forms. Then times 11. Now, you don't need to do this every time, but I do it because it makes it a lot easier to see what they are asking. So what they're asking you to do is to build a highest common factor from the two sets of prime numbers. So to do that, it has to be common to both. So there, we can just circle or loop or ring all of the common factors. So now, if I want the highest common factor, it's just going to be 3 times 5 to the power 3 times 7. And then that is going to be my highest common factor. Now, when doing the lowest common multiple, it's everything that I've just done. So it's all of these. And then, on top of that, multiplied by the remaining numbers. There, there, and there. So to get my lowest common multiple, I'm just going to take my highest common factor, and I'm going to include the additional 2. So we get 3 to the power 4 times 5 with the additional 5, and then times 7 and times 11. Prove algebraically that the sum of any two consecutive numbers of this sequence is always a square number. Alright, so we know that the nth term is describing my number pattern. So that is my first term. My second term would then just be n plus 1. And then if we have a look at my sequence, I've got 1, which relates to 1, and multiplied by 2, which is always my next number, and that pattern continues throughout. Then I've also got a common 2, which stays steady throughout. So that divide by 2 is constant, it doesn't change, but my first number is always the number that I am in line with, so my n. So I can write that down, which is n, and it's always being multiplied by n plus 1. And then it's being divided by my 2. Okay, then if I have a look at my next term, so now I'm going to be looking at my n plus 1, that would just now be this, which you can see there is my starting number, n plus 1, multiplied by going from this piece over here, n plus 2, and that all divided by 2. Now that I've set up my first term and my second term, I can now work to get the sum of any two consecutive numbers. So here's my first number, there's my second number. So now I need to do a sum of them. So n plus 1 over 2 plus n plus 1, n plus 2, all over 2. And it's saying the sum of them. So I can just add them together. Because I've got a common denominator, I can just add those numerators together. And at the same time, I'm going to multiply this in. So I've got n squared plus n squared plus 2n plus n plus 2. And that is all now over 2. Brilliant. So I can bring these together. I can collect my like terms. So that's 2n squared plus n. So I've got 4n plus 2 all over 2. Wonderful. And I can also take out a common factor of 2 so that the 2 divides through all of those. So I'm left with n squared plus 2n plus 1. Whew! Now, the final step. What we need to look at here is we need to prove that the sum of those two numbers is always a square. So we need it to be something like that. So I'm going to factorize this. The factors of these two numbers, 1 and 1, 1 and 1, and there's a nice little trick. Because that is a plus, I know that inside my brackets, when I've set them up, I'm going to have an n there, an n there, and because of this, I know that my two signs within my bracket will be the same as that. So it's a plus and a plus. If it was a negative, they would both be negatives, and if this was a negative, then it doesn't matter what this guy is. The two signs within my brackets, one would be a positive and one would be a negative. But that's beside the point. I'm getting distracted. So we have got those, and then the factors of 1 and 1, or 1 on that side is just 1 and 1. So we can see there that that is just n plus 1, and that is squared. Wonderful. Right, next up we've got a function question. I'm not going to do A and B. I have got videos on that if you do want to have a look at it. But if after watching the videos you still struggle, please do let me know and I'll help you out. We are going to specifically focus on expressing inverse function in the form of that. So we're going to take this function here, and I'm going to want to do the inverse function of it. So my first step is to just switch my x and my y values. So we're going to start with writing it down, I guess. F of x equals x over 4x minus 3. My next step is I'm just going to let f of x equal to y, and then I'm going to switch them straight away. So x equals y over 4y minus 3. So wherever I saw an x, I replaced it with my y, and wherever I saw y, I replaced it with my x. Now I just want to get y to be the subject, so I'm going to get rid of that denominator first. So I'm going to times both sides by 4y minus 3. On this side it would just cancel. So then we've got y equals 2, and I'm going to multiply this in, so 4xy minus 3x equals to y. And then I'm just going to move all my y's to the one side. So I've got minus 3x equals y minus 4xy. And I can take out my common y, which is leaving 4x. So I've got minus 3x there. And then to get it by itself, I'm going to divide by that bracket and divide it on the other side as well. So we then get y equals minus 3x all over 1 minus 4x. And you've got two different options that you can use. You could also take the negative 1 out, or the negative sign out, which would leave 3x over 4x minus 1. But either way, you're going to write that final answer with the form f to the power of negative 1 x on that line. Part D. Part of the curve with the equation y equals hx is shown on the grid. Find the estimate for the gradient of the curve at the point where x equals negative 0.5. Okay, so negative 0.5 is there, so at that point I need to find the gradient. So we're just going to take our ruler and try to form a tangent to our line. And it's not perfect. You will get a little bit of tolerance in the mark scheme when you do this, but let's go from here. Okay, so we've now created a tangent at that point, and all we go do is we go pick two coordinates that we're going to use. So I like this point there, and I like this point there. So this coordinate here is -1, and let's call it 11. And then this one is x is 0, y is 18. All right, and then we just go back to our gradient, which is always change in y over change in x, delta y, delta x, and I just choose 2 points. So I've got 18 minus 11 over 0 minus -1. Just be careful. Don't let that one catch you. So that's 7 over 1. So my gradient is 7. Right, so the diagram shows a sector OAPB of a circle center 0. AB is a chord of the circle. Angle AOB is 80 degrees, so that piece there is 80 degrees. The area of the sector is that, and there's a whole lot of missing information. Work out the perimeter of the shaded segment. So I am going to need to work out this perimeter. Right, so work out the perimeter of the shaded segment, give your answer. We aren't given very much. We're given 80, and we're given this information here. So we're going to work with what we have. We know a couple of things. We know that this is a piece of a full circle. So using that information, we're going to do it. We know the area of a circle is equal to pi r squared, but we also know that that's for an entire circle, and we've only got a piece of that circle. So essentially a fraction of a circle. So we're going to, once we've found out what the area is, multiply it by 80 over 360, because that's the section that we have. Okay, then we look here and we see, oh wonderful, they have actually given us the area. So I'm just going to plug that in. 25 over 2 pi equals, and then pi r squared times 80 over 360. We've got a pi on both sides, so we don't need it. We can just cancel it, because if we divide it through. And then I want the value of r. So I'm going to move everything to the other side, so it becomes 25 over 2. And this was multiplication, so essentially just divide 80 over 360 equals r squared. Plugging that all into a calculator and square rooting, we get that the answer is 7.5. So we've now got 7.5 for my radius. So then we need the circumference of my circle. So circumference equals 2 pi r. And once again, this is not a whole circle, it's just a fraction of it. And wonderfully, I have r and I need c. So I'm just going to plug that in, 2 pi, and then that's 7.5 times 80 over 360. So I get that my circumference equals 10.47. Just remember that we should basically call that x or something, because it's not the full circumference. So now I've got that this section, the perimeter, 10.47. Right, so I have the top piece, and now I just need this section to close off that perimeter. In order to do that, I have got a triangle over there, and in that triangle I'm given, or I've got my two sides and a angle. So what that means is it's not a 90-degree triangle, so don't even try working with SOHCAHTOA or any of those angles. There's no Pythagoras. Pythagoras won't work. So now we're going to work with the cosine rule. So just remember, cosine rule, it looks like this: a squared plus b squared plus c squared minus 2 bc cos a. Okay. And it's always a case that a squared and the side and the angle, and the side are always opposite to each other. And then the other two are just on either side. So plugging all that in, we've got 7.5 squared plus 7.5 squared minus 2 times 7.5 times 7.5 cos of a, which is 80. Wonderful. Plugging all of that into the calculator and then getting a by itself, we need to square root all of that. So we've got a equals 9.64. So my total perimeter is 9.64 plus 10.47, so we get 20.1 centimeters. Write that equation in the form like that, where a, b, c are integers. So straight away, this form here looks like completing the square, or it is completing the square. So I'm going to need to rewrite this with completing the square. So let's do that. First, I'm just going to write it in the standard form. So standard form for a quadratic equation is ax squared plus bx plus c, and obviously that can be plus or minus. So I just want it in that form. So we're going to have minus 2x squared plus 12x plus 5. I do not like that term in front of my x squared for completing the square, so I'm just going to pull it out. So we're going to get minus 2 on the outside, and then x squared is just going to be by itself now, which is what we want. Minus 6x, because if I times that minus 2 back in, I would get a positive 12, and then minus 5 over 2, and there we've got it. So now I'm going to complete the square, and to complete the square, we just look at this term over there, and we always do halve it, square it, and take it away. So we will set up our brackets, x and half of minus 6, minus 3. So that's the halve it. Then we square it and take it away. So we're going to minus 3, and then don't forget the 5 over 2. And on top of that, don't forget my original bracket. Right, so collecting and simplifying as much as I can, I get minus 2x minus 3 squared plus 23. And if I wanted just to write it exactly how they wrote it, it would be 23 minus 2x minus 3 squared. That's your answer. Question 23. The diagram shows a solid pyramid with a horizontal base. The base BCDE of the pyramid is a square, which means all of these sides are going to be the same, so straight away I can put that information in because it's definitely going to help me later on. The vertex A is vertically above center O, so that the base is all the same. The total surface area of the pyramid is 360 centimeters squared. Work out the size of that angle. So the angle that we are looking to work out is that angle there. And they actually don't give you very much apart from that. So that's what we're going to start with, and that's where we're going to start. Okay. Total surface area of my entire shape will be a combination of my base, so the surface area of that, plus all of these triangles. So total surface is going to be a combination of all of those. So my base, 10 by 10, which is 100 plus the area of my 4 triangles, and that will come together to give me 360. We're plugging in a little bit more information. 4 times a half. My base of that triangle is 10, and the height we actually don't know, so I'm just going to leave that as x. Okay, let's clean this up a little bit. 5 times 4, so that's 20x equals 360. Moving everything to the separate sides, we get 260, so x is equal to 13. Okay, so now I have got that, and I can actually put that in, so it makes my life easier to see everything. So that is there, that's 13. Okay, now that I've got that, I need to come back to see where I need to go, and I need to find that angle there. So I know that it is in a right angle triangle, so I can apply things like Pythagoras, I can apply things like SOHCAHTOA. If I can get that length there and that length there, I will be able to do SOHCAHTOA. So let's do that. Next, we're going to have a look and see across there and up there. If I wanted to get this length there, this is actually another right angled triangle, which is great, and I know that this length here already is half of the length of the base, which is 5. So let's go and call this one, my height. So my height squared is equal to 5 is equal to 13 squared minus 5 squared. Plugging that into the calculator, we get that is 12, so I can write that in. Cool, so we've got that vertical height now, and all that's left, this length over there, and that is again in that triangle. It's again a right angle triangle. I've got that is 5 and that is 5, So OC squared equals 5 squared plus 5 squared, which gives us OC being the square root of 50. Cool. Okay, so now we can finally switch to our final color, where we're now working in this triangle. It's again a 90-degree triangle. This is square root of 50, and I'm going to be using this 12. Looking from my angle, this is my opposite, this is my adjacent, and this is my hypotenuse. We can use SOHCAHTOA for this because we need to convert from sides to angles. Because I'm going to be using opposite and adjacent, that means I'm going to be using tan opposite over adjacent. So we've got 12 over the square root of 50, and then I use shift tan to find out that final answer of 59.5.